right session. This is about standards-based management, part of PowerShell Summit 2013. So here's kind of like a high-level agenda of what we're going to be covering today. I'm hoping to spend only about half the time on slides and the remaining time actually in PowerShell demoing some stuff and answering questions. Basically, we're going to talk about, why do we care about standards, why you should care about standards, talk about the specific standards that we align to. We're going to put it all together, talk about a lot of the concepts, how to do it with PowerShell, talk about a new profile that's coming out of the DMTF, and then again, hopefully we'll come at the end for Q&A. So first, let's talk about standards. So this is a comic I like that comes from XKCD. And basically, you kind of read it, there's 3 panes. There's 14 competing standards. Somebody says, oh, I'm going to have a new one that's going to solve everybody's problems. And the reality is you don't actually have this one standard, you actually have 15 standards now. And the reason for that is really legacy. And we'll talk about some of that as we go on, but this is a problem that we have today, and it's probably going to continue for some time. So first, we're probably going to get into this. What we're really talking about here is when you talk about a data center, it's more than just Windows, it's more than just Linux. It's really about the whole thing. There's operating systems, there's hardware, and a lot of the hardware is not running, from Microsoft preference Windows. So how do you manage all that stuff? It's really through standards. So if you're not familiar with, I use a lot of acronyms. We kind of do that at Microsoft. So I'm going to try to explain all of them. I'm going to assume you don't know what it is. IHVs, which is independent hardware vendors, and ISVs, independent software vendors. These are people who produce like the Dells, the HPs, they produce the managed devices. You also produce the software for managing those devices. And why do they care? So they like standards, and again, not all of them do, but the ones that do is very lower barrier of entry. So for a new startup or someone who's trying to enter a new market that they don't exist already, it makes it easier for them to enter that market. By adhering to standards, they automatically become manageable by Windows, by System Center, by PowerShell. And some governments actually requires conformance to international standards like ISO to be even purchased for those government use. And for probably the community here, the IT pros and developers, why do you guys care? We're going to minimize cost of adoption. So if you already had a set of hardware and you want to switch vendors, switch different hardware types, you can reuse that knowledge, reuse that tools. Everything that adheres to the standards that we support will be automatable by PowerShell. And finally, with all these different vendors now competing, trying to be conform with standards, they're not so much looking at proprietary solutions. They're really trying to figure out how do we compete by having better performance, having better reliability, and for better pricing, because they're all conform to the same set of standards. Which does that mean that they can't extend it and provide additional value? Hold on here. Okay. So the standards that I'm talking about come out of the DMTF. This is the Distributed Management Task Force. So this is a consortium of different companies. You can kind of see, here I have a list of just the board members. These are not all the companies that participate in the DMTF. There's actually too many to put on the slide. These are the major ones that contribute not only money, but also people and time establishing these standards. And what the DMTF is really trying to do is standardize IT pro management. You can kind of see some of these are the biggest players in the industry. For some reason, the PowerPoint is not cooperating here. Let me do this. Oh. I think it's a laptop. You want to have a conversation right now? No, I'm just going to switch. I don't know, there's some problem with the PowerPoint on my laptop. I'm going to just switch slides and show it. It's fine. I can work through it. Cool. What this picture represents is the DMTF management technology stack. We're not going to go through all these different things. You don't have to worry about all these different details. What I'm really going to focus on is the CIM schema, and I'm going to dive into each of these areas in a little bit of detail. The web infrastructure, the protocols and bindings, profiles, and finally, management initiatives. Again, you don't need to worry about this diagram right now. I'm going to go through each of the green circle boxes coming up next. Okay, so first CIM schema, which is we'll go from the bottom stack working with towards the top. What the CIM schema really is about is providing consistent modeling for things that you want to manage. This includes both hardware hardware, software, virtual, and logical things. So for example, disk drives, network configuration, processes, services. Again, the one thing to keep in mind is the SIM schema only defines what something looks like, right? So for example, if you had a hard drive, there might be a serial number, there might be a size, there might be a number of sectors, things like that. The schema itself is published approximately 3 to 4 times a year. Things are constantly being added. The current version that's published out there is 2.35. There is both a final and experimental versions. Experimental just means that it has not passed formal ratification through the DMTF. We do encourage people to kind of try them out both for IHP and ISP and provide feedback before we go to standard final. One other thing to keep in mind is if you're not familiar with the SIM schema, it is completely object-oriented, so there's a whole inheritance model behind it, and it's fully extensible. So anyone, either a IT pro or an ISP, can not only implement the schema that DMTF defines, it can extend it, add additional properties and methods, not wait for the next version to come out. All right, so moving a little bit higher up in the technology stack now is WebM, which is the web-based enterprise management. Now, all this really defines is a common set of operations that you can use against any SIM schema or the instances. So this is not a complete list, but these are things that you're probably familiar with. You can get things, you can create things, enumerate things, you can execute methods. One area that is a little bit unique in the SIM model is associations. So if you're familiar with like SQL databases, you have like foreign keys, you have relationships. The only thing that's a little bit unique here is that the relationship itself, called an association, is also modeled as a class and has instances, which also means that some relationships has its own properties and is more than just pointers to two different objects. You can even have methods on relationships themselves. And we're going to show some of that in the demo later on in this session. And I can know this. Okay, so now that we talked about the SIM schema, which is what an object is, we talked about the web infrastructure, which is what can you do to those objects. The next thing is the protocol bindings. So the DMTF itself actually supports 3 different protocols. We really kind of align ourselves with just one of these, which is WS-Man, Web Services for Management. This is a SOAP-based protocol. It was recently, which is approximately like 3 months ago, standardized within the ISO, International Standards Organization, which means that now other companies have voted on it and are going to be adopting it, which means that we're going to see potentially more devices that support WS-Man, which is only good things. And one of the reasons we prefer this protocol is we can reuse a lot of the technology we've already built in terms of HTTP, in terms of SOAP-X and all things like that. Okay, so now we have the definitions of the model, we have the operations, we have the remoting. Now, the thing that's kind of missing here, because again, I kind of explicitly said the model tells you what a thing is. You only know what a hard drive is, what a process is. We don't know how it's supposed to behave, which means that if you have different implementations from different vendors, you cannot necessarily predict that if you do something against vendor 1, it'll behave the same with vendor 2. This is where the profiles come in, which is basically providing not only, here's a set of schema, there's some mandatory things, here's some potentially optional things, and also some clarifying language that says, for this property, the value 1 means this. For this other property, which is a string, it has this particular structure. So now you have some predictability as long as that implementation conforms to a profile, then you can have some assurance that this is going to behave the same across different implementations. So this is actually very important and something that is not new, but something that we're trying to have more adoption within ourselves. And now the first question is, now that we have, let's say that we have a managed device in the black box, and how do we discover that what is the profiles actually implemented on that system? Okay, so here is a UML diagram that I took out of DSP 1033, which is just a DMTF standards publication. This is actually the profile registration profile. So this is a profile that defines how to register other profiles. And the way you should look at this is actually from the bottom towards the top. What you need to do as a management client is you would connect to what's called the interop namespace, and there's really just 4 possible values for that. There's interop, there's root interop, and there's trailing slash versions of that. And once you get to that namespace, then you would find the register profile instance that you care about. And then from there, you do this thing again called association traversal to the actual managed element. And the neat thing about this is, because you're going through the interop namespace, where it says implementation namespace, that could be anything. That could be Dell, could be Broadcom, could be GUID. You don't really care because through the set of operations, you discover what the target namespace ends up being. And I'm going to demo all this in PowerShell. So here's a slightly more complicated diagram, also UML. This is taken from DST 1108. This is the profile that I'm authoring and working through getting standardized in the DMTF. And we'll talk more about this particular profile towards the end. The only thing I've known here is, again, on the upper left, you have the instance for the registered profile. And then on the upper right, you have looking at the previous picture, this would be, the way to explain this is everything on the left side would be in the interop namespace, and everything on the right side would be in the implementation namespace. And through all these associations and relationships, you can actually discover not only the elements on the upper right, the physical computer system view instance that is conformant and is related to the profile, but also any other objects that are associated to it. And again, I'll try to demo some of this so it becomes more clear once we get into PowerShell. So this is why I wouldn't worry too much about a lot of this stuff. It's more academic. Some of the more practical things will come later. Okay, so now we've covered, the schema, we covered the operations, the protocol, the profiles. There's only one thing left, which is for different vertical markets. When we think about vertical markets, it would be like servers, desktops, I think what else? Virtualization. There's a set of things called management initiatives that DMTF drives. Two that you may or may not have heard of is called Smash and Dash. Smash is for servers, Dash is the equivalent for desktops and mobile devices. And what this really is, okay, so now the profile only really talks about how you're supposed to use the schema. Then if you want to tie it all together, make it interoperable, you also need a protocol. So what the initiative kind of does is says, all right, here's a set of profiles. Here's the required protocols. And if you conform with Smash, now again, you have more opportunity to interop with that device. One other thing is called like the system management form within the DMTF certified Smash and Dash devices. And there's pretty much from all the major players some set of devices available that implement Smash and Dash. All right, so now that we went through kind of a little bit rather quickly, but I think the important part is getting to the PowerShell aspect. What I'm going to show you then is, with all the knowledge I just kind of put into your brains, how do we use that and how do we actually do something practical with it? So let me bring up ISC here. For this, I'm going to duplicate this, otherwise it's going to be hard for me to follow. In a minute, there you go. You guys are probably all familiar with this. So let's see how the demo setup. But all this does, this demo setup script, I'll show you what it is. So I'm not tricking, there's no trick behind this. Is I set up an IP address because I don't have it memorized. And then I need to set up a credential I'm going to use to remote to a particular piece of hardware. So you can kind of see, like, again, there's no tricks here. All I'm doing is storing an IP because I don't want to remember it. I'm lazy. And then I have to store the credential that I'm going to use for all these subsequent operations. So again, according to the slide, the first thing I'm going to do is I'm going to create this thing called a CIM session. So if you're familiar with like previous version of Windows, we have these other commands like get wmy_object, get wmy_instance, blah, blah, blah. That's all going over DCOM. It's not standards-based. You can't interoperate. It only works from Windows to Windows. I'm going to show, if you're not familiar with the new set of CIM command lists, you can do exactly the same thing Windows to Windows, which I'm not going to demo here, but you can also do it from Windows to non-Windows. So BRCM so I can remember it. So I created the session, and really, this is a little bit misleading. It's not an active session between my laptop that I'm using as a client and the hardware sitting in the lab. It's actually a cache set of connection parameters, so I can reestablish connections over it. So now I need to actually store that into variables. So I'm going to use the ID since I know there's one. So the first thing I'm going to do is show you all the register profiles that are actually on that device. So we'll do sim session, we'll pass in the session. The namespace, as I mentioned, is we're going to go to the interop namespace. And right now, all I'm going to do is say I'm going to enumerate all the register profiles. You can see there's a lot of them. And in fact, if you look on the bottom, some of these are actually not DMTF standard profiles. The second to last network quarantine profile is actually a Broadcom specific one. So again, there's nothing that says that OEMs cannot do their own extension, do their own value add, but at least the language and the protocol is the same whether I talk to Broadcom's profile or talk to DMTF profile. So what can we do now that we have? So let's get let's do it this way actually. I don't know if there's a way to zoom in this thing. Probably with it. So what I'm going to do is I'm actually going to get this base desktop and mobile profile because it just happens that I know that that's kind of like one of the central profiles on Dash. So let's do that base desktop mobile profile. Actually, cheat here. Unfortunately, the device I'm using doesn't support queries, so I actually have to do the filtering using PowerShell. I can't do it over network, the server side. Where's it? Didn't know I'm working. Alright, so now if I do that right, which I didn't, there's a typo here. Now I have that instance. So what this is just the representation that there is an implementation of the base desktop mobile profile on the remote device. And what I can do from here is I can just look at everything that's associated or related to this particular profile. So I'm just going to pipe in. You can see there's a ton of stuff. And in this case, what I really want is the CIM computer system instance. There it is. So I'm going to store that. I'm going to use it in a subsequent part of the demo. You kind of see there's a lot of rich information here. There's like the GUID of the machine, there's a MAC address, there's the asset type, serial number. Go back to let's see, duplicate okay. And this is just a sample, PowerShell code that I just went through, or the equivalent. All right, so that was really just kind of like a simple introductory. We discovered the profiles. We got one of the profiles. We went from a profile to the instance. Let's do something a little more complicated. One common operation that you would do against hardware is you power on and power off thing. So here in this UML diagram, this comes from the power state management profile, which is the way we're going to do this is we're going to, again, we have the computer system instance. But if you look on the lower right, we start from, again, the register profile. We're going to find the register profile instance that is for power state management. We're going to traverse from there and get the associated instance for the power management service. One thing that I didn't mention is for all these classes, they leave off the CIM underscore in the front just for make it easier to read. There's no reason to have it there, but that is on there for each of the classes. And then for the power management service, then we need to actually, in theory, if we want to do it completely correct, we check the capabilities to see if it supports power on prop. We're actually going to achieve because in most cases you can try and fail, it will work just fine. But the power management service, there is a request power state change method we're going to use, and then we need to pass in a reference to the object we want to change the power state of. That's why I needed to keep the CIM computer system instance. Because in theory, the power management service can actually turn on and off and put in a standby any device that is supported on the system. It could be a fan, it could be other things that support power. Let's try that. So, okay, power management profile. Actually, let's save some type. Our management profile. Skills that enable the power state. Okay, so now that we have the other profile that we care about, we need to get the power management service. Let's see, power management service. So let's go ahead and store that power management service. And if we just did a, see, there's a few things associated with it. There's like capabilities, and you have to look in a profile to understand what all these numbers mean. There's this other thing, out-of-band management service, which we're not going to care about right now. And there's the computer system. Of course, there's the profile itself is also associated. So now, what we want to do is invoke CIM method. And in this case, this is a dynamic method, so we have to execute it on the instance. So let's go ahead and pass in the power state. What do we call it? Service. So I should argue that. Let me go back here. So here, again, this is another section that comes out of the power management service. This is a table that shows the method we're going to call, which is the request power state change. On the top table, you can see there's a bunch of parameters. We're going to supply the power state. We're going to provide the reference to the object we want to change the power state of. There's an optional time parameter, like I can change it at 8 p.m., 6 p.m. We're going to change it now, so I'm going to supply that one. There's this optional potential help object called a job. So basically, you'll see this in a lot of CIM methods, and what it is if you execute this operation, and the operation may take some time, then what you'll get back is this thing called a CIM job. And then you can actually query this job, repeatedly pull it, you can subscribe to indications to find out, what's happening, is it complete, did it error? In this case, because this operation doesn't take very long, we're not going to get a CIM job back. And finally, there's a timeout period where if you send a request and it takes too long, rather than not knowing what happens, you want it to just fail. So we're not going to set that either, that's optional. Now for the power states, you can see a lower table, which I don't have the complete list because I kind of cut it off to show what's really relevant here. You can see what all these magic numbers mean. So 2 is power on, 3 sleep, blah, blah, blah. So actually, before I turn it on, we should probably find out what state the device currently is in, because I actually don't know. So the way we're going to do that, cheat a little bit because I just forgot. Okay. So there is this CIM associated power management service association instance that I need to get that actually tells me what the current power state is. So this is what's a little bit more complicated. So if you saw I have this get CIM associated instance commandlet, we actually don't have, as of right now, this other commandlet for getting referencing instances. So when you get the associated one, you actually don't get the associated instance, you get the 2 endpoints. If you actually need to get the relationship itself, you would need to call this, right now it's exposed as a .NET method, enumerate referencing instances. And basically we need to supply the namespace, the parent object, and then the target name. So let's go ahead and do that. Service. And then there's there's one other parameter which is for the result. In this case, we're just going to pass in null strings as we want, whatever comes out of it. So here, again, if you look at power state, it says it's 4. So let's go back to the slide deck. And 4 says it's currently in a deep sleep. So if it's in a sleep, we're going to turn it on, which means that we're going to provide a value of 2. So that was here. This requested power state was just the last time we requested a change. It was a 2, but since that time, it put itself to sleep. And the only other thing that might be interesting is here, these are all the available power states that actually I can request. So I can turn it on, I can do a 5, which is a power cycle. I can power off soft and whatever 10 was. So let's go ahead and go back to what we're doing. So let's see. So we want to set power state to I'm going to use a special PowerShell syntax rep. It basically says don't actually send the object, but send a pointer to the object, which is all this method really wants. And we have stored that here. Since everything else I'm not caring about, I'm just going to leave those off. Those are optional. And if it succeeds, then return value is 0, which means if it succeeds, if you get a non-zero value, it means that something else happened. So if we do this again, then now it says that the machine is turned on. So of course I don't have it here. You can see it actually power on. It's kind of neat. All right. So far, what I've done is you got the power state management profile. In this case, it is assuming that you've actually, unfortunately, read that profile, which is a huge PDF with a bunch of diagrams and text. But once you do that, then you understand how to make use of it, and basically you got to do all these relationships and whatnot. So it's still really kind of complicated. I think most of you agree, except for the hardcore people. So what I'm going to show next is there's this thing that I produced. It's not complete. It's a work in progress. It's already published on TechNet, which is a module to simplify a lot of this, and hopefully over time some of that capability will be in Windows itself. So let me do that. So I already have it here. So I'm going to import this module. So let me just show you everything that is supported. So here's the command that's currently exposed to this module. We're going to probably talk more about later. But to show the same thing that I did previously, I can, for example, let's get pressure profile. I'm going to use the same CIM session that I established earlier. And one thing that I do, because I know that, if you do this a lot, you actually need to, you don't want to get the profiles each time. It's very expensive. I kind of cache all that in the background. One other thing, there's a couple things you might notice here, if you quick eyes. One is I added formatting, so instead of having this list, it actually has a view of what I think is most important. But previously, if I did the, of course, show that up here, you can see like this register organization has all these numbers, 1s and 2s, which for most people, they don't want to memorize that. So actually format that to actually mean 2 is DMTF, 1 means other. And in the case of other, it shows that these are actually broad column specific ones. Similarly, we have a Git computer system. So this will automatically find the relevant profiles like base desktop, base server, computer system, whatever, and then traverse the association to get the actual computer system instance. And again, if we were to format this, you can see there's the same information is there. In this case, again, I kind of replace a lot of these DMTF standardized numbers with actual human readable text. So the current state or the enable state, which is not the same as the power state, is CLES, which in theory means it's sleeping. So the OS, actually not the OS, but the computer system has 2 different states. This is where it gets a bit complicated, which we don't talk about it offline, we come back, but there's an enable state, there's a power state, they're 2 related but different things. But now there's a whole set of power state stuff. So let's go back here. Then if you recall, I had to originally get the profile, get the power management service, I had to get the referencing associated instance to find out what the current power state is. I kind of abstract all that through this command, and I can kind of see, again, I added the text. It's currently in a deep sleep and went back to sleep because I didn't do anything with that machine. In fact, I don't think it actually even has an operating system set up, so I'll probably just keep with Because it's a test machine, I can't depend on anyone else not turning it off and trying to use it, or they can depend on me. So now, if we wanted to turn this back on, it would look more like this. And in fact, we have this enumeration, so you can actually just select and delete it. And it says it's successful, so we can get the power state. And again, it's back on. So you can kind of see, it is, I think it's important for, if you're doing advanced things, to understand the profiles, understand all the operations, because again, I'm only abstracting a set of specific operations that an IP pro might do. This right here. But you know, I think these are probably the most common things that people do, is like the top 80%. If you need to do like the 20%, then you're gonna have to understand CIM, understand the profiles, and do all that yourself, which is not hard, but it's not fun. So currently, again, like the DMTF, if you go to the DMTF.org and look at the management profiles list, there's actually a ton of profiles. There's stuff related to virtualization, related to fans, sensors, hardware, software, stuff like that. Right now, I'm only kind of focusing on these particular areas, which is more aligned towards if you just got a new piece of hardware, it's set up for remote management, how do you first install the operating system? And so that's why I exposed this capabilities. So for boot control, which I can show, which is you can set up for Pixie boots, you can boot it off of your network and install operating system and whatnot. Let's see if I can do that here. So let's get the current boot order. So according to the hardware, it is currently set up to do a one-time boot off the CD-ROM drive. Last time I tried this, I think I had a problem with this. So I need to store these, I'm going to call these boots S. So each of the objects here is just a custom PowerShell object that I decorate. So I want to set boot order. I want to do this one time. Let's see. This is 0, 1, 2, 3, 4, 5, 6. So what happens? Okay, so now if you hit the boot order again, it should show that I change it to network boot instead of CD-ROM, or the next time I reboot the device. That's what it shows. So one thing I'll call it here, because this is one of the complications we've encountered as even we're trying to abstract this stuff. There's a couple of things I'll talk about. First, there is, unfortunately today, this concept of one-time versus persistent. So if you look at the list of devices, you kind of see there's a bunch of repeated things, right? For example, CD-ROM shows up twice. It's very unlikely there's actually 2 CD-ROMs on this piece of hardware, a desktop system. There may or may not be local NICs, but right now I know there's only physical one. There's only one hard drive and one USB. And one of the complications is the way that DMTF modeled it, and this is because the people who create this model is mostly the implementers, the hardware people, that Dells, HPs, and whatnot. So they're looking at how do we create a model that's very easy for to implement because we've already got the hardware, versus how do we make it easy to consume. So one of the results is you have this concept of a persistent boot control configuration, and then you have a separate concept of a one-time boot control boot configuration. And unfortunately, because of those associations, right now they only associate one device to each config. So basically, they have to duplicate those devices to associate it with the 2 different configurations. That's why the things show up twice, even though their indexes are different. It's actually the same device. So this is one thing I'm trying to help work through the news, how to make that a little more simple. The other thing you might notice on the structured boot string, this is actually not intended necessarily to be for the human consumption. But the result is actually the easiest way in many cases to have interoperability across different vendors. The reason is that this element name is completely opaque. Like in the case of Broadcom, it says boot order hard drive, but in the case of Dell, for example, it could just say just hard drive or hard disk, or it might say hard drive with a dash. The same problem with the structured boot string, where here the structured boot string means that the profile says that this property must have a string that has a organization, a identity for the device, and an index. And basically, in this case, Broadcom chose to use VRCM, even though this is an HP system. One of the things that the profile has tried to do is standardize on these strings. So if I say CIM:network, then I know that it will work on any performance system from HP, Dell, whatever, rather than saying Broadcom network or Intel Pixie or HP NIC. Those may all mean the same thing, so we don't need heuristics. But there's a problem that exists today, and I'm working towards how to make it a little bit simpler, but it's going to take time. So just a caveat if you try this at home, so to speak. So these are, actually I didn't show the hardware and software. So when we get hardware inventory, it actually, if you can quickly see up on top, it actually goes through a lot of different profiles. There's a physical asset, there is the processor, I think the system memory. So here, using different profiles, again, this is not a single profile. I'm actually using 3 different profiles that do a whole bunch of different operations that's really covered. I'm retrieving what I think right now is the relevant information that you probably care about. And we can do the same thing for software. The software here doesn't mean software that's installed on the operating system. This is software that's in the hardware. So this is primarily like firmware, like BIOS, management firmware, and things like that. In the industry, it's still called software. One thing I will try. So a lot of times, of course I don't have any data, so sometimes this works, sometimes the hardware has some issue. Where basically I'm trying to enumerate different sensors, and you can see there's 4 different sensors. There's temperature sensors, tachometers. Right now the communication status is that there's no contact between the motherboard or the BMC that's in the management and the sensor that's somewhere else on the motherboard. So I'm going to show those values. Now, this is something I intend to continue to improve upon. I haven't had time because I've been working on this thing called Windows. But these are some of the things I'm looking for in terms of order of priority, simple identity management. So this is, so a lot of the demos I showed, I kind of have this account already set up on the hardware. This is the administrator account. I have my own password. But how do you manage additional accounts? How do you manage the first account? Then once you have the account, how do you set up the roles for that account? Is it an admin? Is it just an observer of some sort? Text console redirection. This is if you were to boot into the BIOS. If you had a headless system, if you want to make changes in the BIOS, or if you wanted to use DOS or whatever, or you're in a console mode, there's ability to manage all those settings and also redirect that to either Telnet SSH. Yet similar entry. So hardware on the BMCs, there's a thing called CEL, which is a system event log. So we can let's get the record log first. Show you this. And basically, if there's any events that happen in the hardware, it'll get logged into this log. So for example, if you have chassis intrusions enabled, and anyone opens up the case, then it'll log an event. If CPU temperature goes over a certain threshold, if a fan fails, they'll all get logged into the record log. So this command is for managing the log, not the logging entries. But if we wanted to see the actual entries, I may not have anything in this one. I can just pipe it to get log entry. Right now there's only one log in here, or one log entry. And I believe, because I did not add the capability to render this in human readable form, I believe this log entry is for the log has been cleared. So the last time I cleared it, it logged that it was cleared. Okay, so let's talk about the next thing. So again, I showed you all the underlying technology that comes from the DMTF. I showed you the profiles. I showed you even the module to make it simpler. But even with the simple module, you're still incurring a lot of network traffic because under the covers, when I do like the boot control or the power state, there's actually probably like 10 or potentially more operations we're going to have to get an instance, get a relationship, get this other relationship, invoke a method, get the results, blah, blah, blah. One thing is I'm going to do now is using this thing called a physical computer system view profile, solve it by making it more simpler from the consumer side, but it actually happens that it's actually simpler from the management side as well. So the way this is going to be here, this looks complicated, but it actually is. Trust me, it's not. In the profile, the only thing I really define is this upper box. So basically, I take capabilities that most people care about, and it comes from this other standard called DCMI, if you're CIM, that data center management interface, which comes from IPMI, which is the Intelligent Platform Management Interface, comes from Intel. Basically, I looked at, for booting, for looking at memory, looking at hardware, looking at software. I take pieces of those different profiles, which I think people most care about, the 80%, and I stuck all that into a single class, which is the physical computer system view. So rather than having to manage what looks like 10 to 11 different classes, there's only a single class that should cover the 80% of the use case that you care about. What these other boxes show on the bottom, kind of look like an octopus, is that a piece of hardware can't implement the physical computer system view that satisfies the 80%. But if it already has or wants to implement the full profiles, then what this diagram shows is that you can actually traverse from the physical computer system view, this is a view class, to the full classes that conforms to the other standards. So that's really all it's showing is that this is a complementary profile that simplifies both the implementation as well as the consumer, but it doesn't prevent anyone from having everything if the customer demands it or the implementer already has it implemented. So where do you guys kind of come in, being part of the PowerShell community? I think one of the things that we're moving towards is I think we have a great story for automation from Windows to Windows. We're still trying to figure out, how do we move it towards beyond that? How do we make sure that you can manage and automate the whole data center? Right now, we have a set of commandlets that talk standards. So if you guys, again, want to, read up on the profiles and do all that, you can do that today in Windows Server 2012 and Windows 8. We also have the WMF Windows Management Framework WTR release. We have a release that goes down the hole. So even from 1.7, and I think this was supported on the last one, you could actually use all the same CIM commandlets and manage existing hardware that's in the market today using those standards. But the thing we're trying to figure out is, all right, how do we make the experience better? Are there scenarios that you guys want to light up that you can't light up either because it's hard to figure out or because we don't have certain features implemented? Let us know, and then we'll prioritize it. We'll try to work together. We'll try to provide a workaround with nothing else. I was kind of at the end of my presentation. I think my time is up actually, about 2 minutes. So I do infrequently, less than I like to, blog on this. What used to be the WMI blog, we kind of refactored it to be the Windows management. I think we call it infrastructure now, versus so it's a little more broad. So if you guys have any topics, my email is here. Assuming it doesn't somehow, I apologize if your email's really going to spam folder. I don't check it, but if it doesn't, then I will read it. I'll try to respond. Send me questions. I want to hear about your experiences trying to manage hardware. I want to hear about what works, what doesn't work, and we can use that information to try to make it better. And I'm generally available. Other than that, if you have any topics about blog entries, again, I tend to write a little bit more technical stuff. So if you're interested in that, then take a look at the stuff that I've written already. Otherwise, any questions?
Thanks, sir.